Hello everyone, my name is Abhishek and welcome back to my channel. If I ask you to containerize this application, on the first go you might say, Abhishek, this looks like a complex application and I don't have experience working on such applications. But trust me, after watching this video, you will find it easy because in this video, I will explain you step by step how to containerize such real-time applications. All that you have to do is to watch this video till the end, and after watching, practice the same steps on any cloud platform of your interest. Specifically for this video, I will use Google Cloud Platform. I will run all the steps on Google Cloud Platform. However, you can use AWS, Azure, Oracle Cloud, DigitalOcean. It doesn't matter. Overall, what we will learn in this video, I will do a quick recap of Docker. Then I'll explain you how to install Docker on a virtual machine, how to containerize real-time JavaScript applications, what are the usual steps, how to use container registry. In this case, we will use Docker Hub. So how to push and store images onto Docker Hub. Finally, how to run containers in the background and expose the applications within the container to outside world. We have a lot of things to cover in this video. So without wasting any time, let's get started. First things first, why Docker has become very significant. So there are two primary reasons why Docker has become very significant. First thing, Docker solves the classic problem between system administrators and developers. That is, it works on my machine. So basically, if you look at world before Docker, developers, they are working on their applications, and let's say developers were using Windows machines, and system administrators or DevOps engineers, because they have to deploy this application end of the day to production, let's say they were using Linux operating system machines. So developers used to deploy and test their application on the Windows environment, and system administrators used to deploy and test it on the Linux environment. There are plenty of cases where the application used to work perfectly fine on Windows environment, but when it comes to the Linux environment, application either was not working or not working as expected. Now, this is a problem not because of the application, because of difference in the configuration between the machines. Even in Linux, there are different distributions, tens of distributions. Developer can use CentOS, and Linux administrator might be using Ubuntu. Developer might be using Debian. System administrator might be using Alpine. So this difference in configuration was a very big challenge for IT. Now Docker solved this problem using the concept of containers. So Docker said, hey DevOps engineers, all that you have to do is to take your application, bundle your application as a package along with your application dependencies and system dependencies for your application. Now bundle them into a package called container, create an image out of it, and share that image to the Linux administrators, right? So if developers create this image, all that they have to do is to share this image for the Linux environment, and this image perfectly works fine on the Linux environment as well. So through containers, Docker solved this problem. Now the second problem was resource utilization. When I say resource utilization, I'm talking about CPU, memory, typically compute. Before Docker, organizations were extremely underutilizing the resources. Now, if you take companies who were only using physical servers. Imagine an application was deployed onto a physical server. Usually these physical servers are rich in resources. Let's say some 100 CPU, 100 GB RAM. This one application might not require all of these resources. Typically, applications don't need so much resources, especially in the world of microservices. So plenty of resources were wasted. Now, this problem was solved to some extent using virtual machines, because virtual machines are can break down physical server into logical multiple machines. So this problem was solved by virtual machines to some extent, but even companies were underutilizing the virtual machines. Typically, companies were deploying one application per virtual machine, and this virtual machine, when it is created with 4 CPU, 4 GB RAM, for example, application was not even using these resources 100%. So what companies have done, they moved to microservice architecture, and Docker was the best fit for this microservice architecture. Now, using Docker, companies can run, like if company takes a virtual machine, on this, they can install Docker engine, and through Docker engine, a virtual machine can be broken down into multiple logical containers. And within each container, DevOps engineers can run a single microservice. So this way, and even Kubernetes does the same thing. Kubernetes is a cluster of virtual machines where on a single virtual machine, which we call as node, multiple containers are run. In fact, you can run hundreds of containers as well. So through containers, organizations also figured out effective resource utilization. So Docker solved two major problems. One is it works on my machine, not your machine. Second, effective resource utilization. If you want to understand more about it, I just covered high level information about it to give you a quick recap of Docker. But if you want to learn more, I have a free Docker playlist or a free Docker course where I have explained all the concepts of Docker in detail, right from what is Docker to the latest Docker features such as Docker model runner and Docker offload as well. So you can go through this playlist. I'll put the link in the description. Now let's see how to install Docker on a virtual machine, right? Because we want to deploy this application. We will not be deploying it on a physical server, obviously. So we will first take a cloud virtual machine, install Docker on top of it. Then we will learn what are the steps to containerize this application. As I told you, I will use Google Cloud Platform. So I will head to the Google Cloud Console. Great. I'll create a project. So every time you do something on Google Cloud Platform, right? It's better to create a project for your hobby project. Within your organization, you might already have a project, but for a proof of concept, create a project. Once you are done with the project, disable the billing for the project and delete the entire project. So that way you will not incur any charges. If you're practicing this video, even on your free account, you might be costed some, less than $10. So if you have a free account with at least $10, you can definitely practice this project. Okay, going back, create the project name. So I'll just call it as Docker demo. No organization because I'm using a free account. Great. Now the project is being created. It typically takes less than a minute. Cool. So we have the Docker demo project. Let's head to it. We will be creating a virtual machine. So to use virtual machine, we need to enable Compute Engine API. So head to Compute Engine. Once you click on VM instances, you will find an option to enable Compute Engine API. Click on the enable button, wait for a couple of minutes, and you will have your Compute Engine API enabled. Then you will be able to create virtual machines. Cool. So the Compute Engine API is enabled. Now, if we go back to Compute Engine and click on the VM instances, we should see an option to create the instance. I will call this instance as Mario instance. Always choose the region that is nearest to you so that you will not run into latency issues. Availability zone, that is data center. You can pick up anything. Unless you are running production workload, I would not recommend to go with compute optimized or memory optimized. Of course, not GPU for this kind of use cases. So go with E2, which is low cost day-to-day computing. At this point, it is $30. So you can bring it down if you go with E2 small. I wouldn't recommend E2 micro for this demo because it's not such a simple application that it can run with E2 micro. Let's go ahead with advanced configuration. Perfect. Everything is fine. OS and storage. I'm fine sticking to Debian. We will use Docker anyways, so it doesn't matter which operating system are you using. Commands are mostly the same. Data protection. I don't need it. Networking, observability, advanced. So in advanced, I will change the VM provisioning model to Spot. The only disadvantage of Spot instances, they can go down anytime, but I'm perfectly fine with it because it's just a proof of concept. I'm just using it for my learning purpose. So I'm okay if the instance goes down and a new instance comes up. Cool. So one more thing is that in the networking configuration, I'll just add a network tag for this virtual machine so that I can apply firewall configuration for this virtual machine, right? So if you click on the question mark, you will see assign network tags to apply firewall rules to a specific VM instance. At the end of this video, we will expose the application in the container to outside world, right? So to expose the application to the outside world, you have to have the port open. So we can do it in Google Cloud Platform using the network tags. If you're on AWS or Azure, you will be using NACL or you would be using security groups. In Azure, you would be using ASG, application security groups, right? So it depends on the cloud platform. This is the only difference that you have to take care of, right? In Azure, you might be going with network security group. In AWS, you might be going with security group. In Google Cloud Platform, we will go with the network tag. So I'll just call the instance of, I'll just apply one network tag, that is Mario. Click on create. We will have our instance created in a couple of minutes. In the meanwhile, while this instance is getting ready, let's try to understand the source code point of view. Lot of people ask me this question, and this is where people are worried. Abhishek, as a DevOps engineer or as a cloud engineer, do I need to understand the source code? Do I need to have programming knowledge? Right? So should I have to write this application? The answer is absolutely no. So let me simplify this for you. As DevOps engineer, you will not be working with a single programming language, right? So for one team, you might be working with Java-based application. For the other team, you might be working with .NET. For the other team, you might be working with a JavaScript family of application, Rust, Golang. So it is technically impossible for you to be good at multiple programming languages. You need to know the following things. Number one, you should understand the structure of the application. Right? For example, if it's a Java application, you should know that you will either find the dependencies in pom.xml or If Gradle is the build language, you will find the dependencies in the Gradle file. Or if it's a Python application, you should know that there is a requirements.txt file written by the developers. If it's a Golang, you should know that there is a code.md file. It's not that difficult. With practice, you will understand these things, right? Initially, you might find it overwhelming. Today, we are dealing with a JavaScript application. There will be something called package.json. As I told you, initially, you will find it overwhelming that, Abhishek, how should I remember these many files? But you are technically not writing these files. You just look at these files to understand dependencies of the application. Second thing, you need to know how to build the application. And finally, you need to know how to deploy the application. If you know these things, you can be a very good DevOps and cloud engineer. It doesn't matter which programming language it is, you only have to know these three things. If you are a single DevOps engineer, you don't have a senior engineer in your team, what you can do is you can collaborate with the development team, because end of the day, DevOps is a culture that unifies development and operations. So you can discuss with your development team, you can set up a meeting with them and understand what is the structure, what are the steps to run the application locally, and you can take care of deployment. Deployment through containers or deployment onto Kubernetes cluster. But these 2 points, you can also set up a meeting with the development team because they already know where the dependencies are declared. They already know how to build the application because they have done it on their local environment. Even before developers share the application with the QE or share the application for the development, they do all of these things locally. Define the dependencies of the application, build the application locally. They also deploy it, but they just deploy it to the local environment through some development servers. So you can ignore that part, right? For today's application, the Super Mario application that we are dealing with, this is a JavaScript application. In fact, this is a TypeScript application, but it belongs to the JavaScript family. Now, for any JavaScript application, imagine you joined an organization as a cloud engineer. It doesn't matter the scale of the application, you will find a file called package.json. And this file will have all the dependencies to build the application. You will not be writing this file. Developers will write this file when they build their application locally. What you will do within this particular file, you will write the script section, right? So this is a section that you define within this file. How will you define the script section? Again, as I told you, if you are a new DevOps engineer, you can have a conversation with the development team, but most likely these scripts will be, so Vite is a development server, or Vite is a mode to deploy and build TypeScript applications. So you will write a script called dev. This is all the script that you have to write. Dev Vite, build Vite build. Okay, so this is the step to build, and this is the step to run the application locally as a development server. But Abhishek, what is this dev and build doing? Where are we invoking these commands? You invoke these commands using npm, Node Package Manager. Okay, so as DevOps engineer, to build the application, you will run the command npm run dev, and this dev will look at package manager, package.json, and it will understand what exactly needs to be done, right? I shared the same steps in the README file as well. So if you look at the README file of this application, so you will see start the development server or run the application locally. The command is npm run dev. Build the application, the command is npm run build. Now, when you run npm run build, npm, which is a node package manager, it looks for this build script within the package.json file. And in the package.json file, you have to define the script section In the script section, you have to write the value for the build keyword. So the value for the build keyword, mostly when you're going with TypeScript applications, is build. If this is a Python application, instead of package.json, you will find requirements.txt, and instead of npm, you will be using pip, right? Pip. So here the command would be pip run, pip install -r requirements.txt. If you are using Golang, the command would be go build or any equivalent command. So this is all what you need to know as a DevOps engineer. Then the complexity comes into picture when you're dealing with containers, Kubernetes. It's a different game, right? If you have time, I would highly recommend after watching this video to go through this entire README file. So I have tried to put all the details. What is the structure of the code? In which order the code is structured? What are the commands? What are the core components? What are the prerequisites? Even the Docker commands that we are going to run, I have put everything within this README file. I'll put the link in the description for this repo, so you can go through it and run the same steps. Going back. Okay, now we have the VM instance as well. The status is the green check mark. That means instance is running. Now there are two ways to connect to this instance securely. One, you can use Cloud Shell, or second, you can use SSH. I will use Cloud Shell for now. So I'll click on the authorize button and I have access to this VM instance. Now the first thing is to install Docker. Even before you clone the source code, you have to install Docker. So as first step, I will run sudo apt update to update all the packages. If you're wondering why do we run this command, basically the OS image might be bundled long time back and there can be new version of the packages or there can be new dependencies for this operating system or this flavor. So that's why whenever we install a VM, we run sudo apt update. Okay, I'll increase the font size a bit. Now, the next thing that we do, once we run sudo apt update, we have to install Docker on this machine. Now, once we install Docker, I'll explain the Docker lifecycle as well. So let's try sudo, I hope the command is right, apt install docker.io. Okay, so it says it does not find the following packages have unmet dependencies. So let's try a different command. Instead of sudo apt install docker.io, so I'm looking at official Docker documentation. So we'll follow the same steps. One is we ran update. So I'll copy these commands and let's try to run, or let me do it step by step. Going back from the official Docker documentation. Okay. So the packages are getting updated related to Docker. Done with it. Next step is to add the package to the repository and run update one more time. Great. So once we are done with it, now we can just run this command, install the Docker packages. Okay. We have them installed. You can see all of them are installed. Finally, let's verify the Docker installation using docker run hello world. So this is just a command to verify that Docker is installed on our machine. Cool. So when you see this output, that means you have Docker installed. You will find these steps in the documentation as well, or at least I will share the link to this document. So you don't have to worry how to install Docker on this Debian virtual machine. Create the same Debian virtual machine on AWS, Azure, or any cloud platform. Cool. So we have Docker as well. What are the next steps? What does a cloud engineer do with respect to Docker? There are 3 steps. Number 1, to containerize, you have to define a Docker file. So what do you put within the Docker file? As I told you, a container is a combination of application along with dependencies of the application and system dependencies. So within the Docker file, a DevOps engineer first provides the operating system flavor, right? So creates within the container image, Docker engineer provides, DevOps engineer provides a OS flavor for the Docker image, then copy the source code into the Docker image or into the Docker file, through the Docker file into the image. Once the source code is copied, copy the dependencies as well. Of course, first dependencies are copied, then the source code is copied, and finally download the dependencies and run the application. So these are the steps that are typically written into the Docker file. Now let's start with step by step. That is, we will define a Docker file here. So vim, the name of the Docker file, we will just keep it as Docker file itself. So the first step we will start with from node colon 18-alpine as build. So basically what I'm trying to do here, now I will use a multi-stage Docker build. In the first stage of the container, I will build the binary of the application or build the package of the application. And in the second stage, I will just run the package or deploy the package. So the reason for doing this, the reason for going to a multi-stage Docker build is to reduce the container image size and also to significantly reduce security issues with the container image. You can also do it in a single stage. You can put all the commands in one stage and just remove this alias. But what happens? Your container image will be huge, the size of the image, as well as it is prone to security issues. Okay, first step, we choose a OS flavor or a container image for this particular Docker file. What does this signify? Node 18-alpine. So this means we are using Alpine base image with Node.js of version 18 installed already on that Alpine base image. So I don't have to install Node.js already. You will find tons of such images in the Docker Hub. So if you go to Docker Hub, you will find huge number of images already put. You will find Alpine base image with Java. You will find Alpine base image with Golang. You can use these base images so that you don't have to install those base packages. Okay. Then we will choose a work directory. So we will choose a work directory such as /app. You can pick up any work directory. Basically, this is the folder within your container image. Once you have the container where all the commands are being executed. Now we will copy the package.json file. As I told you, first we will copy the dependency related file package.json to this folder. And then we will run npm CI. When you run this command, all the dependencies in the package.json will be installed within the container image. Now, once the dependencies are copied and installed, then it is a good practice to copy the source code. Now, this is a little advanced concept in Docker. The reason why we do it in 2 different steps. The first step, Why we copy the packages, install them, and then we go with the source code? Because Docker uses a concept called caching. So if you isolate both of these stages, the build time for your Docker container creation or the image creation will significantly go down. Okay, then we will run npm, my bad, npm run build. So if you remember, where are we getting these commands from? Either you can get these commands from the developer, or with practice, you know these are the commands that you run when it comes to TypeScript or JavaScript programming language. So we are done with the first step. So this is stage one, where we have built the application within the container image. So you can just call it, for your understanding, we can just call it as build stage. And the second stage is deploy stage. Here what I'll do is I will choose again the same base image from node colon 18 hyphen alpine. Again, I will choose a work directory slash app. This time I will copy only the binary that is created in the first stage to the second stage. So copy hyphen hyphen from is equals to build. So from this particular stage, I have created alias for this stage. So from this stage, I will just copy the artifact that is created by npm run build. So npm run build usually creates the artifact within the dist folder, right? So dist is the artifact that is created, and the working directory is slash app. So I'm copying slash app slash dist from this particular stage of the container image to dot slash dist folder. Okay, now we have the workload as well, or we have the binary as well. So what I will do at this point is to just run this binary along with a HTTP server. So run npm install -g HTTP server. Because to expose this application, we need a HTTP server. We need a HTTP server to run the application as well. So using npm install, we have the HTTP server, expose 8080 port to the outside world. We will be using this port, right? This does not export anything, but this is just for kind of a metadata. Finally, in the entry point or in the CMD, we will use the HTTP server that we have created, right? Followed by where we have the artifact, we have it in the dist folder, -p, my bad. So we have it in the dist folder, -p. -p stands for the port. So basically we are providing the command HTTP server dist -p port 8080 followed by -c -1. So this is the same command that you provide whenever you are dealing with JavaScript or TypeScript applications, and when you want to run it within a HTTP server. First time you might find that, okay, what is this command? But because you keep repeating the same command again and again, you will get used to it. Now let's save this. Perfect. So we've saved the Docker file. We wrote the Docker file. What is the next step? Next step is to create an image. So you have written the Docker file. You have to execute the instructions or run the instructions within this Docker file. When you run the instructions within this Docker file, typically when you build the Docker file, an image is created, and this image will have everything that you have written in the Docker file. So this image will have the base image that you have chosen, plus application source code that you have copied and the image that you built, that is the binary that you have built, right? because we have chosen multi-stage build, it will just have the base image along with the binary, along with HTTP server that is executing your binary, right? So let's go ahead and create this image. How to do it? Going back to the terminal, the Cloud Shell terminal, Docker build -t. I will call it as Mario game version 1. Okay, let's try to do it. Followed by dot, which says this is the location of the Docker file. If your Docker file is in some other location, you have to provide the path for it. Because it's in the same folder, I'll just say dot. Okay. So at this point, if something goes wrong, that means you messed up with your Docker file. So I've done the same thing. I messed it up. Let's see what is wrong. So it says npm CI could not complete it successfully. Maybe I missed something. Let's look at the Docker file. Run npm CI. Before that, I copied the package.json. Okay, it looks good. What's missing here? Node 8 in Alpine. Run npm CI. Okay, it looks good to me. Let's go back. Solve did not complete successfully. Okay, let's look into the log further to see what might have happened. Clean install. Okay. So the reason why it is failing, basically, we forgot to copy the source code, right? So it tried to copy the source code, but we don't have the source code here, which is a blunder that we have done. So let's copy the source code. Click on copy button. Git clone this. Okay. Now we have the source code, Super Mario Mimic. So we will just copy the Docker file onto it. Copy Docker file to Super Mario Mimic. Okay, let's switch the directory. Great. So we have the source code along with the Docker file. Now let's try to run it. So I'll run the same instruction, Docker build. Cool. So let's see this time if it is able to run the same thing. Okay, perfect. Even the HTTP server is getting executed. If this is done, we have our image created. Cool. Okay, if I do Docker images, I should see that image. So we have the image Mario game v1 tag. Now, once we have the image, the final step or the third step is to run the image. So we executed the Docker file, we got the Docker image. Now, once we execute the image, we get the container. And within the container, application is running. But how do you run the image? So to run the image, we will use a command docker run -it. So IT is for interactive, but if you want to run the container in the background, you can just use -d. Okay, let's run it in the background. Docker run -d -port. So we will use 8080 as the port, colon 8080, followed by name of it, Mario game, colon v1. You can also use this image ID instead of Mario game colon v1. Okay, now we have it running in the background. We can verify Docker PS. So we can see that it is running perfectly fine. We can take the instance IP address and try to access it. So basic information, external IP address. Do we have an external IP address for it? Yep. So this is the external IP address because I haven't restricted it. Browser copy 8080. Okay. So it's not working because either on Google Cloud Platform or AWS, Azure, any cloud platform, by default, ports are blocked. You have to enable the port by defining the firewall configuration. How do you do that? Just search for firewall. Okay. And within this firewall, you have to add a new firewall rule to open port 8080. So I'll call it as Mario. One thing that you have to make sure is, you have to use the network tag, the same one as the network tag that you have chosen for the instance. Name can be anything. That's okay. Disable the log, default VPC, because we have the instance in the default VPC. Incoming traffic. Okay. All the instances in the network, specify target tags. Do you want it to keep it open for all the instances? No, I don't want it for all the instances. I have defined a tag for the instance. Honestly, I don't remember it. So I'll just go back and see what is the tag. We can get that information. So if we search for compute, okay, compute engine, VM instances. So basically we have to provide the same tag. Otherwise, you can just allow all instances in the network. Scroll it down. Okay, compute engine, VM instances. This is the instance. Let's see what is the network tag. I'll just search for network here. Okay, so the name of the network tag is Mario. I'll provide the same thing. Instead of all instances, specify target tags, Mario. IPv4 ranges. Let's allow all the IPv4 ranges. So anyone on the internet who is trying to access our applications, they should be able to do it either from your laptop or any other thing. Specified or all the ports. No, I only want port 8080 to be open. We learned all of these things in the previous classes. We learned about AWS and Azure as well in our AWS and Azure courses. Perfect. So after a few seconds, we have this application running, right? So this is how you containerize applications. The difficult part is that you have to practice various programming languages. But as you get used to these programming languages, you will realize whether it's a complex application or a simple application, steps are more or less the same. In this case, from source code point of view, this is a complex application. But for containerizing the application, we must have hardly spent 30 minutes of time. I know I haven't deep dive into the concepts of Docker because one more time, I have a free Docker playlist on this channel where I have covered Docker right from basics. So that is one of the reason why I did not deep dive into Docker. I'll put the link in the description. At any point of time, if you have doubts related to multi-stage Docker build, you can go through it. If you have any questions related to basics of Docker, you can also go through the videos in this particular course. I hope you found the video interesting. I encourage everyone to go through this particular video and implement it on your side. See you all in the next video. Take care, everyone. Bye-bye. See you.